Okay, so this is like take 20 because my phone keeps ringing with sales calls while I'm trying to film. So impulse changes in momentum. Here is an important document I think you're going to want to have. This is reminding you of some information. So impulse problems, important equations to know are the equation for momentum and the equation for impulse. And it's really important here to pay attention to units, okay? Sometimes the problems have a requirement for a unit conversion. And what I wrote here is that in this point in the curriculum, marking period 4, freshman year, in this far into algebra and into physics, we have done so many conversions that it's important that you recognize the necessary units, and you'll be expected to make those conversions as part of your meeting the standards. Impulse, here's the equation for impulse. I equals F times delta T, force times the amount of time that force is applied, the elapsed time. And because we know that impulse changes momentum, you can set those two equations equal to each other because the impulse will cause the change in momentum. And what we get is force over an elapsed time is going to equal the mass times the change in velocity. Usually we're not changing the mass of the object, we're changing its velocity as we change its momentum. Just in case, I provided some conversions that would be necessary. Kilograms to pounds. Remember, some of you, I throw that in there in case something's in pounds, but remember, this is the key one. We always are working in kilograms, but when we talk about weight, we're talking newtons. So a lot of you keep wanting to go to pounds. I know because we live in the United States and we're not physicists all the time. But when we're talking about weight, we want it as a force in newtons. Oh, I did not include the conversion there for a mile. So let's double check that here. How many meters are in a mile? How many meters are in a mile? 1609.3. 1609.3. 1 mile is 1,609.34 meters. Okay, I'm going to put up a photograph of this worksheet as well for you. Okay. The other thing I wanted you to remember here is when you're talking about velocity, sometimes it's not to trick you, it's to make you think. You're going to know the distance something might move backwards in the amount of time it moved. And you're going to possibly get confused and wonder, how am I getting velocity? And remember that velocity is calculated by doing a change in distance divided by a change in time. So if you know the distance an object has moved backwards or moved forward, and you know how much time it took to do that, you know its velocity, or rather you can calculate its velocity. So some of these problems may have multi-steps, either including a conversion or adding in velocity. Now I'm going to set up my iPad here so that I'm not so shaky and that I can demonstrate some problems worked out for you. All right, stay tuned.